Hi guys, in the last two lectures we have covered two topics. One is the parallel operation of the transformer, in which we saw necessary conditions for parallel operation and how load is shared between the two transformers if they operate parallel. Then we saw auto transformer, which was a transformer in which secondary and the primary winding were not isolated from each other, rather a part of winding was common between primary and secondary, due to which power was being transferred by two phenomena. One was induction and other was conduction. So these two topics have been covered in the previous lectures. In this lecture what we will be doing is we will be solving a few previous year gate problems that have appeared from these two topics. Okay. So let us get started with our first problem. It is saying a 400 by 100 volt two winding transformer is reconnected as an auto transformer across a suitable voltage source. The maximum rating of such an arrangement could be. Now we know S auto is S2 winding by 1 minus K. So for S auto to be maximum, K should be high. If you increase K, the denominator will decrease and net term would increase. So rating of the auto transformer would be high if we increase the value of K. Now there can be certain possible combinations, like it can be 400 by 500 volt auto transformer in additive polarity or 100 by 500 volt auto transformer. In this case, in the first case, K1 would be 0.8 low voltage by high voltage, that is 400 by 500. In the second case, K will be 100 by 500, 0.2. Since this K is higher, that means it will result in a larger value of rating. So we will use 0.8 value, that is 10 upon 1 minus 0.8, 10 by 0.2, which is 50 kVA. So this is the maximum rating of the auto transformer that can be achieved from this two winding transformer. Okay. So this is, we have assumed additive polarity, because in the last lecture we saw that additive polarity has a higher value of kVA as compared to subtractive polarity. So by default I am assuming additive polarity, and then there can be two cases. Primary can be applied across 100 volt and secondary or primary can be applied across 400 volt. Okay, but one voltage should always be 500 volt due to additive polarity. Okay, so let us move on to our next problem. In our next problem it is saying a 50 kVA 3300 by 230 volt single phase transformer is reconnected as an auto transformer. What is the nominal rating of the transformer? Okay. Now here if you see, the low voltage is in the auto transformer 3300 volt, high voltage is 3530 volt. So transformation ratio, which is low voltage by high voltage, is 3300 by 3530. So we can say rating of auto transformer is rating of two winding transformer by 1 minus K. Okay, which is equal to 50 into 3530 by 230. It comes out to be 767.4 kVA. So this will be the rating of auto transformer. Whenever additive polarity is given, you can directly apply the formula that rating of auto transformer is 1 upon 1 minus K times rating of the two winding transformer. This formula you can directly use for the case of additive polarity. In our next problem it is saying two transformers are to be operated in parallel such that they share load in proportion to their kVA rating. The rating of first transformer is 500 kVA and PU leakage impedance is 0.05 pu. Rating of second transformer is 250 kVA. Its PU leakage impedance is. I told you whenever load is proportional to rating, then Z per unit 1 should be equal to Z per unit 2. where per unit impedances are defined on their own basis. Okay. If you do not remember this, then watch the lecture on the theory about the parallel operation of transformer. There we derived this expression that whenever load is proportional to rating, then per unit impedance of both the transformers must be equal. That means Z per unit 2 is equal to 0.05 pu on a base of 250 kVA. Since it hasn't been said that on what base we must find, we'll assume that we'll find the per unit leakage impedance on its own base. Okay. Since it hasn't been specified, so I am assuming that we have to find on its own base and not on any different base. Moving on to the next problem. It is saying a single phase 50 kVA 250 by 500 two winding transformer has an efficiency of 95% at full load unity power factor. Now it is reconfigured as 500 by 750 volt auto transformer, which means it is connected in additive polarity. Its efficiency at its new rated load and unity power factor. Now first of all, auto transformer is 500 by 750 volt. So low voltage is 500, high voltage is 750. So transformation ratio, which is LV by HV, 500 by 750, which is 2 by 3. Okay. So if we find the rating would be 50 upon 1 minus 2 by 3, that is 150 kVA. Okay, this will be the rating of auto transformer. Now we need to find the efficiency. For finding the efficiency, we need first of all losses. Losses can be found out using the two winding transformer. It is given 0.95, which will be, it is full load, so X is 1, kVA is 50, cos phi unity power factor plus loss. Okay, into 100% we will not do because we have taken on the left hand side 0.95. So if we calculate losses from here, loss comes out to be 2.63 kilowatt. Now if we want to find auto transformer efficiency, it will be full load, that is 1, 150 kVA is rating, unity power factor is 1, and losses are 2.63 into 100%, it will come out to be 98.27%. So if you see, auto transformer efficiency is higher than the two winding transformer because rating has increased, but we are assuming that the losses are same. Usually the losses are lesser in auto transformer as compared to two winding transformer, so actual efficiency will still be higher than this calculated value. Okay, the efficiency that exists in practical will be higher than this. Let us try our next problem. It is saying the figure shows coils 1 and 2 with dot markings as shown, having 4000 and 6000 turns respectively. Both the coils have rated current of 25 ampere. Coil 1 is excited with single phase supply 400 volt. If VAB is 400, then VCD will be N2 by N1 into VAB, that is 6000 by 4000 into 400, which is equal to 600 volt. So the voltage on the secondary side is 600 volt when the primary is excited with a 400 volt. Now let us see our first problem based on this. It is saying the coils are to be connected as a single phase 400 by 1000 volt auto transformer to drive a load of 10 kVA. Which of the given options should be exercised? Now we want primary to be 400 volt and secondary to be 1000. 1000 is nothing but 400 plus 600. That is, we need additive polarity. So how to connect the coils? This will be primary. 400. Now we need to add the secondary voltage. It will be like this. This is A, B, D, C. So here if you see A and D are same, and the common terminal between primary and secondary is B. So option A would be correct, that A and D should be connected together and B terminal will act as a common terminal between the primary and the secondary winding. Let us move on to next problem based on the same data. In the auto transformer obtained in previous question, we need to find current in each coil. So let us first draw the auto transformer. This is my primary winding. This entire is secondary. 400 volt, 1000 volt. Okay. Now it was said that load is 10 kVA. So let me find the load current is 10 kVA by 1000 volt, which is equal to 10 ampere. So current going here would be 10 ampere. This is 600 tons. This is 6000 tons. This is 4000 tons. Now we know input and output kVA rating must be equal. So source current would be 10 kVA by 400, which is equal to 25 ampere. So 25 ampere will go like this. That means in this winding by KCL it will be 15 ampere. Here 10 ampere, here 15 ampere. So this way current will be divided in different coils. In coil 1 it will be 15 ampere, in coil 2 it will be 10 ampere. Okay. This way you need to calculate the currents. Using the load we can calculate primary and secondary current or source and the load current. And then by applying KCL we can find the current in different branches of the auto transformer. In our next problem it is saying two single phase transformer A and B have the following parameter: 400 by 200 volt 10 kVA. Per unit percentage resistance and percentage reactance means per unit into 100. So we have been given per unit impedance. The other transformer is 5 kVA, but voltage rating is same. Okay, that was one of the necessary condition in parallel operation, that voltage rating of both the transformers must be same. It has a per unit impedance 0.04 plus j 0.03. Now they are connected in parallel and a common load of 12 kilowatt 0.8 power factor lag is connected. We need to find active and reactive power of our transformer A. Now I told you whenever we use the expression for parallel operation, that is SA is equal to ZB by ZA plus ZB conjugate, then here ZB and ZA must be either in ohms or on the same base. Now if you see, the base for transformer B is 5 kVA and for A it is 10 kVA. So let us convert it to a uniform base. So I am assuming that base is 10 kVA. Voltage is anyways same. So voltage will be 400 by 200 volt. So since this is already on 10 kVA, no need to transform this, but we need to transform this impedance. Z2 new will be Z2 old into S new by S old into V old by V new square. Z old is 0.04 plus J 0.03. S new is 10, S old is 5. Originally it is given on a base of 5 MVA, but we are converting it to 10 MVA or 10 kVA. But voltage rating remains same. So this is 1. So it will be 0.08 plus J 0.06 pu. Now both the impedances are on a same base of 10 kVA. let us divide the load. First of all, let us find SL. SL will be PL by cos phi, 12 by 0.8, which is 15 kVA. So it is 15 angle 36.86 degree kVA. I told you for a lagging load, power will have a positive angle. Now let us apply the expression for the load sharing. SA would be 15 angle 36.86, then Z2 is 0.08 plus J 0.06 plus 1.1 plus J 1.0. Okay. Now put this into the calculator and what you will get is, this will be 0.11 and this will be 0.1. 0.11 plus J 0.1. Now if we plug this into the calculator, we will get 7.467 plus J 6.78. Now here the real part will give me real power, that is 7.467 kilowatt, and imaginary part will give me reactive power, which is 6.78 kVAR. So this is the real and the reactive power supplied by the transformer A. Okay. So keep this expression in mind while solving any parallel operation. In our next problem, it is saying 2300 by 230 volt 50 kVA 50 Hz transformer is connected as an auto transformer to supply a 2300 volt circuit from a 2530 source. That is, auto transformer has a rating of 2530 by 2300 volt. So here low voltage is 2300 and high voltage is 2530. So if we find the transformation ratio, it is equal to 10 by 11. 230 will divide both the terms. Now to find the rating, we will do 50 divided by 1 minus k, that is 550 kVA. So this will be the rating of the auto transformer. Okay, just rating of the two winding divided by 1 minus k. Now let us try the last problem. In this it is saying two single phase transformer with equal turns. Equal turns means their primary and secondary voltage is same. Have impedance of 0.5 plus J 0.3, 0.6 plus J 1 ohm with respect to secondary. Now if they are connected in parallel, how will they share a load of 100 kilowatt at 0.8 power factor lag? So first let us find SL, which will be PL by cos phi, that is 100 by 0.8, which is 125 kVA. Now to find out SL in phasor terms, we can write as 36.86 degree kVA. Now to determine SA, what we will do? Since both are in ohms, no need to change any basis. It will be SL ZB by ZA plus ZB conjugate. Okay, so this can be written as 125 angle 36.86 multiplied by ZB is how much? 0.6 plus J1. ZA plus ZB will be 1.1 plus J 1.3. Okay. So if we simplify this in calculator, we will get SA will be 75.86 kilowatt plus J 39.64 kVAR. Okay. If we determine SB, it will be 125 angle 36.86 into ZA. ZA will be 0.5 plus J 0.3 divided by ZA plus ZB, that is 1.1 plus J 1.3. This will come out to be 24.14 kilowatt plus J 35.34 kVAR. That means PA will be 75.86 kilowatt and PB will be 24.14 kilowatt. So this is a universal expression that can be applied to any parallel operation of transformer. So these sort of questions can only be framed in the GATE examination. In parallel operation, you have to remember the necessary condition and how the load is shared. In auto transformer, you have to remember two things. One is how the rating varies from the two winding transformer, and the other thing is how to calculate the efficiency of an auto transformer. So this is all from the transformer topic. From our next lecture, we will start our new topic, that is the DC machines.